Astronomers have a way of sounding calm when they say the most unsettling things. Not long ago, in a handful of routine status reports and late-night observation logs, a quiet pattern began to emerge. 7 comets, all on long, lonely journeys from the dark, were discovered to be heading inward toward the Sun, but converging into the same narrow window of time. On its own, that would be enough to make professionals reach for fresh coffee and double-check the math. Yet here, in this brief slice of the 21st century, the inner solar system is preparing to host a procession. 7 visitors, 7 different orbits, 7 separate discovery stories. And then, as if the script were not already strange enough, something else enters the frame. An object that does not belong to our Sun at all. A fragment from another star's ancient disk. The third confirmed interstellar visitor humanity has ever seen. Astronomers call it 3-Eye Atlas. It is not bound to our star. Its path is not a closed loop like the planets. It moves on a one-time hyperbolic curve, dropping in from the deep between the stars and then slipping away again, never to return. For most of human history, such a thing would pass unnoticed. Now, with sensitive surveys sweeping the sky, we can see it coming, and we can see something else. When you place the arrival of this interstellar wanderer on a timeline next to those 7 comets, the dates begin to bunch together in an uncomfortable way. The year that welcomes a rare visitor from another star system is the same year a small swarm of bright comets reaches its own peak. The kind of overlapping that makes you pause, lean back from the screen, and wonder whether the universe is nudging you to pay attention. The odds, as one researcher put it in a conference hallway, are non-zero but unfriendly. That is the polite way of saying that if everything is truly random, this is a remarkably baroque coincidence. Of course, coincidence is not illegal in astronomy. Randomness has all the time in the universe to arrange its surprises. Yet there is a different possibility, one that sits just far enough beyond our current understanding to keep people awake at night. It is the idea that these objects are not simply arriving together, but have been traveling together in a looser, more subtle sense. That what we are seeing now is only the final act of a journey that began far from the quiet orbit of Earth. A swarm has been following 3-Eye Atlas into our solar system. Not like a fleet in a science fiction story, moving in rigid formation on a captain's command. More like the way leaves follow a branch down a river, separated by distance yet carried along by the same current. Or the way fragments of glass scatter from a single impact, some pieces racing ahead, others falling behind, all tracing paths that point back to a shared moment long ago. If that image is even partly true, then every point of light in this strange year's sky is more than a curiosity. Each comet becomes a small, bright clue about the environment that shaped 3-Eye Atlas before it ever crossed the invisible frontier of our Sun's gravity. Perhaps they are siblings, born in the same distant region and parted by time. Perhaps they are only distant cousins, stirred into motion by events we cannot yet see. Perhaps they are strangers, whose paths simply happen to rhyme. Tonight, we are not going to leap to conclusions. There are enough loud voices on the internet eager to tell you that everything means more than it does. Here, we will do something quieter and more demanding. We will walk slowly through the evidence. We will trace orbits. We will listen to what the data actually says. And we will be honest when it falls silent. Along the way, you will hear about the year the sky stopped feeling empty. You will meet each member of this 7-comet procession and the interstellar wanderer that seems to share their stage. You will see how scientists test ideas that brush the edge of the unknown without falling into fantasy. And you will be invited, gently, to decide for yourself whether this is coincidence or the outline of a deeper story. You do not have to solve that puzzle tonight. You do not have to remember every number or every name. So, as the music sits low in the background and the day's concerns fall a little further away, imagine stepping out under a dark sky. Imagine 7 faint smudges and 1 silent traveler from another sun, all moving in their own way toward the same central fire. Because if a swarm really has been following 3i Atlas into our solar system, then what is arriving is not doom, but a rare chance to watch the cosmos improvise. And all you have to do, for now, is listen. Most years, the sky keeps to itself. It offers a predictable rhythm of planets, a handful of meteor showers, and every now and then, the faint arrival of a comet that only dedicated observers bother to chase before dawn. This quiet is the rule. It is what makes the night sky feel steady, almost meditative, even when life on Earth is not. A normal year might host 1 comet bright enough to trend on astronomy forums, or none at all. And most of the others, those pale, slow travelers that drift inward from distant reservoirs, appear only as soft, ghostly smudges in telescopes, barely bright enough to stir conversation outside a few niche communities. That is what a typical year looks like. But 2025 does not look like a typical year. Instead of the usual quiet scatter, this season brings a small crowd. Not a noisy crowd, not a dangerous one, but a noticeable one. 7 comets, each with its own past and path, are all brightening as they approach the sun. 7 objects with tails that reflect sunlight in long, elegant arcs. 7 opportunities for people around the world to step outside after dinner, look up, and catch something rare. A cosmic visitor bright enough to photograph or see with binoculars. For astronomers, this is the equivalent of rounding a corner on a normally empty street and finding a line of headlights stretching into the distance. The road itself hasn't changed, but something is clearly happening. In a year like this, the sky feels crowded. Crowded not in the sense of danger. None of these comets are on collision courses, but in the sense of timing, proximity, and the sheer number of bright photogenic objects sharing the same season. Amateur photographs start appearing from Chile, from Arizona, from rural Japan. Reports trickle in from people who rarely pay attention to astronomy, but notice an unusual streak above the horizon. The sense builds slowly, quietly. This is not how most years go. It is particularly striking because comets are not appointments on a calendar. Each one is governed by its own orbit, stretched, tilted, elongated, often taking hundreds or thousands of years to complete a single trip. They do not coordinate. They do not travel in formation. They do not consult each other before deciding when to appear. And yet, in 2025, here they are. 7 of them, lighting up the sky like a convoy at night. For people who enjoy analogies, the comparison is irresistible. Imagine a stretch of rural highway where you might see 1 car every 20 minutes. Then imagine that one night you hear engines, several of them, and watch as a sequence of vehicles rounds the bend, headlights spaced apart but clearly heading in the same direction. You would not assume disaster. You would not assume conspiracy. But you might wonder why this night is different. Astronomers are wondering the same thing. They are not raising alarms or forecasting calamity. No one is whispering about impacts or danger. Instead, the conversations sound more like curiosity with a raised eyebrow. Why this year? Why this cluster? How rare is this overlap when compared to the historical record? How many visitors does it take before coincidence starts to feel like a pattern? This tone of calm interest becomes even more pronounced when you place these 7 comets on the same yearly timeline as 3i Atlas, the interstellar traveler whose arrival already makes 2025 unusual. One visitor from another star system would be enough to mark the year as special. But one visitor from outside the solar system accompanied, in the same season, by a small swarm of comets from within it, gives the entire period a sense of motion, of ingredients mixing, of something approaching from multiple directions at once. It does not imply purpose, but it does imply statistical rarity. Comet specialists compare charts, overlapping the light curves and predicted visibility windows. Orbital dynamicists look at timing. When each object brightens, when it reaches perihelion, when it becomes most visible to observers on Earth. Over and over, the same impression forms. This is not what a quiet comet year looks like. This is a year with unusual structure. And because human beings are storytellers, the presence of Three-Eye Atlas casts a long shadow across this structure. It is no longer a lonely traveler entering the inner solar system. It is part of a season marked by motion, by visitors arriving in loose succession, by a sense that the region around our sun has, for a brief span of months, become a busier neighborhood than usual. If you step outside under a dark sky on a night when one of these comets is visible, you may not feel the crowding immediately. Space is vast, and even a gathering of objects millions of miles apart will still look peaceful from Earth. But the story behind the quiet view, the way all these orbits intersect in time, is what gives 2025 its character. The sky doesn't often feel busy. When it does, astronomers take notes. In the coming moments, we'll take a closer look at each of the 7 comets, their discoveries, their paths, their personalities. One by one, we'll meet the members of this strange procession, and the picture will grow clearer, detail by detail. Not to force a conclusion, but to understand why so many scientists are leaning forward this year, watching the sky with a bit more attention than usual. Let's meet the members of this strange procession, one by one. When astronomers describe a year as busy, they do not mean noise or commotion. They mean that when you chart the sky, when you stack the discovery dates, when you map the orbits and brightness curves, the page begins to fill with more lines and dots than usual. In 2025, those lines have names. They behave like characters in a cast, each entering the stage in turn, each carrying its own story, and each quietly, almost politely, aligning itself with the others in a loose, drifting procession. Not a march, not a formation, but something subtler, a suggestion of motion in the same general direction, separated by years, yet converging into the same season. To understand why the year feels crowded, it helps to meet them one by one. The first is Pan-STARRS, often called the Pathfinder. It comes from the All-Sky Survey that has become one of astronomy's most reliable early warning systems. Pan-STARRS watches the heavens with patient, repetitive scans, catching faint objects before most telescopes know where to look. This comet stood out early, bright enough to draw attention, predictable enough to offer observers a fair chance of capturing it from different hemispheres. Pan-STARRS announced itself as one of the opening notes of the year, the way a single instrument tests its sound before the rest of an orchestra joins in. Its appearance did not raise alarms. It simply opened the door. Then came SWAN, the early flarer. It was not discovered by a ground telescope at all, but by SWAN, the solar wind anisotropies instrument aboard the SOHO spacecraft. SWAN detects hydrogen, and this comet revealed itself by glowing in that wavelength long before it was visible to the naked eye. That early activity gave it the feeling of an eager runner warming up before the race even begins. It flared just enough to gather interest, brightened earlier than expected, and seemed almost impatient to enter the inner solar system. In any other year, SWAN would have been a charming curiosity. In this year, it felt like another piece of momentum. Stereo followed next, the solar grazer. This is the kind of comet that approaches the sun so closely, it risks boiling away. Some survive, some shatter, some glance past the corona, with a tail stretched thin and trembling under the force of solar wind. Stereo earned its nickname because it appeared in the cameras of the Stereo spacecraft as it skimmed the sun. Watching a comet do this is like watching a small boat enter a storm front. You know it will be changed by the encounter, even if it emerges intact. Stereo's passage showed, in dramatic fashion, how comets interact with plasma, with radiation, with the invisible turbulence that surrounds our star. Its inclusion in the year's timeline is a reminder that each member of this procession experiences a slightly different sun. Atlas K1 arrived with more anticipation than most. It was the hyped one, the comet that early predictions suggested might flare into something spectacular. That excitement faded as more measurements came in, revealing a dimmer reality. Yet even without living up to the initial expectations, Atlas K1 arrived at just the right moment to deepen the sense of sequence. Its timing fit the pattern, even if its brightness did not. It slid into the year almost modestly, as if stepping into line with the others. Atlas G3, the quiet anchor, carried none of the buzz. It did not promise fireworks or headlines. Instead, its orbit placed it in the middle of the year's cometary schedule, like a steady heartbeat between more noticeable events. Its predictability and placement made it feel like the hinge of the timeline. It is the kind of comet that usually earns a footnote, but in a year shaped by patterns rather than individual brilliance, G3 becomes part of the glue holding the sequence together. Lemon came after, the mid-column. Observers often describe comets in terms of their individuality, but Lemon is memorable here because it sits almost exactly in the center of the sequence, not too early, not too late, not too bright, not too faint. It gives the swarm the feeling of continuity, preventing the procession from feeling like two clusters with a gap in between. Lemon's orbit, when plotted, looks like the middle link in a chain of icy travelers moving inward. And finally, Neat, the one we knew was coming. Neat has a long history, and its return this decade was no surprise. Astronomers had penciled it in long before 2025 arrived, yet the coincidence is hard to ignore. A predictable comet returning on schedule is not unusual, but for it to do so in the same year as 6 other bright or notable comets, and in the same year an interstellar visitor enters the scene, makes the pattern feel denser. Neat's presence is like the last member of a group arriving on time for a meeting none of them planned. When you take each comet separately, the year feels lively. When you place their orbits on a sky map and draw the routes they have taken to reach the inner solar system, something else appears. Each of these comets began turning inward years ago. Their approaches were shaped by long arcs carved through the outer darkness. And when you mark these arcs on a timeline, you can trace them like beads on a string, sliding one after another toward the sun's warm gravity well. Behind them, far behind, yet aligned in a way that becomes visible only when you zoom out, lies the hyperbolic path of 3I Atlas. Looking backward through time, their routes form a faint procession trailing into the distance, like a dotted line of icy signatures following the interstellar traveler. Patterns don't appear in single points. They emerge when you finally zoom out. Now that we've met the swarm, we have to ask a harder question. Is this truly unusual? Or just how randomness looks up close? When people first hear about a cluster of comets arriving in the same year, the easiest explanation is the comforting one. Maybe we're just getting better at noticing things. After all, astronomy has never been more capable. Surveys sweep the sky every few hours, Telescopes compare images in real time. Software picks out faint dots humans would never have seen 20 years ago. With so many eyes on the heavens, perhaps it only feels like the sky is getting busier. That line of thinking is understandable. It is also incomplete. The first distinction astronomers make is simple but crucial. The difference between how many objects exist, how many we detect, and how many become bright enough to matter to the public. Better technology helps with the first and second categories. It lets us find more faint comets, more distant asteroids, more minor bodies wandering through the outer regions. But brightness is not something technology can manufacture. A comet becomes bright because of its composition, its distance, its geometry with the Sun and Earth. No telescope on Earth can force a dim comet to become a spectacle. It either does or it does not. That is why the events of 2025 cannot be written off as a simple artifact of better tools. Surveys can increase the number of discoveries, but they cannot summon 7 bright comets into the same season or arrange for an interstellar visitor to swoop in from beyond the Sun's influence at precisely the same time. That combination remains an outlier against the backdrop of decades of sky records. Even with better telescopes, you don't usually get 7 big comets and an interstellar guest in one brief window of time. This matters because astronomy depends on statistics. A single object is interesting. 2 is a coincidence. 8 in one compact slice of the calendar forces a second look. And when you add the distinctive path of 3I Atlas to the equation, the questions multiply. The comets belong to the solar system. The interstellar visitor does not. Yet their timelines now overlap. Not because astronomers were looking harder, but because these objects were already on inward trajectories, long before any survey attempted to find them. This is where the phrase "has been following" reveals its weight. It is not a suggestion of intent. It is not an implication of purpose. It is a reminder that celestial mechanics has a long memory. When we run the orbits backward through time, we uncover the truth that every object in this swarm began its inward arc decades or centuries ago. No telescope was there to witness those early bends, those quiet nudges from distant giants, those gentle gravitational pushes that slowly steered these bodies toward their rendezvous with the inner solar system. The pattern we see today is not the result of modern observation. It is the result of past events, ancient encounters with planets, frozen choices made by gravity, subtle interactions with the outer edges of the Sun's domain. The comets were already committed to this year long before humanity learned how to detect them. And 3I Atlas was already crossing the dark between stars, committed to its single pass through our neighborhood, before the first humans learned to walk upright. This is what makes 2025 special. The timeline was set before our species existed. Only now do the paths intersect. Technological improvement cannot account for that. Better cameras do not create synchronized perihelions. More frequent sky scans do not line up brightness peaks. And no advancement in detection can turn a loose scattering of inbound comets into a well-structured sequence that just happens to coincide with an interstellar arrival. This is why astronomers are neither dismissive nor alarmed. They occupy the middle space, the thoughtful, careful ground where questions are asked with patience. There is no claim of hidden meaning, no whisper of signals or messages. But no one hastily waves away the data either. Anyone who spends a lifetime working with orbits knows to pause when many paths converge at once. Astronomy teaches us to be humble with 2 words: sample size. In this context, 2025 is not simply another year with more surveys. It is a statistical outlier that invites deeper investigation. It challenges assumptions about natural clustering. It encourages researchers to compare long-term models, to examine how comets migrate inward, to explore whether the same gravitational disturbances that once nudged these comets could also have shaped the path of 3I Atlas. It does not attach a conclusion. It simply sharpens the question. Perhaps the most grounding realization is that every orbit visible today carries the imprint of forces applied long ago. A comet approaching the Sun this year may carry a trajectory shaped by a brush with Jupiter in the 18th century. A faint object brightening now might have been nudged into motion by a collision of ice fragments hundreds of thousands of years before humans kept written records. The patterns we notice are only the closing notes of long, slow processes playing out far beyond our awareness. And so the responsible conclusion is neither dramatic nor dismissive. It is simply honest. This year stands apart. It sits in the narrow category of moments when randomness produces something worth examining more closely. It refuses to settle into the background. It demands the same attention we would give to any surprising cluster in a dataset. Not because it must mean something, but because ignoring it would mean overlooking an opportunity to learn. In a moment, we'll see if any hidden force could actually herd a swarm like this. If something is guiding this swarm, it has to speak the language of the universe. Forces, not intentions. To make sense of a swarm, the first place astronomers look is not mythology or mystery, but gravity. Gravity is the quiet architect of everything that moves in the solar system. It shapes the long, looping paths of comets. It sculpts resonances and gaps in the asteroid belt. It teaches planets where to stand and how to dance. Over billions of years, it turns chaos into a kind of order. An order built from the pull of mass across empty space. Whenever several objects arrive together in one season, gravity is the natural suspect. If there were a hidden planet out there, something massive, dark, and distant, its presence would betray itself. A world even half the size of Neptune would twist orbits in recognizable ways. Comets would not just fall inward, they would be steered. Their tilts would cluster, their eccentricities would shift, their long periods would carry similar signatures, as if they had all been brushed by the same unseen hand. If there was a hidden planet herding this swarm, its fingerprints would be all over the sky. They're not. When astronomers plot the orbital elements of the 7 comets, the lines don't converge towards some external shepherd. There is no common bend, no shared kink, no peculiar clustering in inclination or perihelion direction. Each comet behaves like a traveler with its own long history. Gravity may have nudged them over centuries, by Jupiter, by Saturn, by distant encounters with one another, but they do not point back to a single cause. The patterns are suggestive, but the dynamics are independent. Nature rarely hides massive objects. If something big is there, it tugs on everything around it. So the idea of a giant, lurking body doing the organizing falls away under examination. No sign of distortion, no mass signature, no unaccounted for gravitational anchor. Whatever is happening, it is not the simple, cinematic version of a hidden planet rounding up a group of icy wanderers. Gravity does not support that story. When gravity fails to produce an explanation, astronomers look toward fields, the invisible forces that ripple through space. The Sun is not just a ball of fire, but a generator of winds, storms, and magnetic currents. Its outflow of charged particles, the solar wind, fills the solar system with a constant, restless tide of plasma. This wind sweeps comet tails outward, reshaping them into long blue streamers. It bends, twists, breaks, and reconnects filaments of ionized gas. The Sun's magnetic field stretches and warps, carving vast spirals of energy that the comets must pass through. These effects can be dramatic. When a coronal mass ejection sweeps across space, Comet tails can snap like ribbons caught in a gale. Some tails fragment and scatter, others brighten in sudden, ghostly pulses. Yet these transformations affect only the tail, the glittering atmosphere around the nucleus. They do not steer the solid heart of the comet itself. The nucleus, a compact block of rock and ice, is far too heavy and stable to be pushed into formation by magnetic fields alone. Fields and plasma can create beautiful synchronicities in the sky, but they cannot align orbits separated by millions of miles. They can choreograph appearance, but not approach. And yet, there is a middle ground worth acknowledging. Not everything in astronomy is explained by planets and magnetic storms. Beyond the solar system lie larger structures, galactic currents, moving groups, ancient streams of debris drifting around the Milky Way. These are not forces in the everyday sense. They are environments. They are slow rivers of stars, dust, and frozen bodies drifting together through the galaxy. In that wider context, it becomes easier to imagine a different picture, not a shepherd pulling a swarm behind it, but many objects set on similar inward paths because of a shared origin long ago. Perhaps 3I, Atlas, and these comets were never coordinated. Perhaps they simply occupy the same broad flow of material drifting around the galactic neighborhood. In that sense, the idea that a swarm has been following is less about purpose and more about perspective. When you zoom out far enough, patterns begin to reveal themselves, not as acts of intent, but as echoes of formation. This does not mean there is a hidden field or mysterious funnel shaping the exact sequence of 2025. There is no strong evidence for such a structure, but it reminds us that the solar system is not isolated. It sails through a larger sea, and that sea has currents of its own. Gravity and fields within the solar system may not be producing the cluster we see today, but the long histories of these objects, combined with their distant origins, can place them on paths that appear coordinated to us only because we are seeing them now, at the end of their journeys. The result is strangely comforting. Nothing is guiding the swarm in the dramatic sense. Nothing is arranging these objects with intent. But nothing about 2025 suggests randomness either. What we see may be the natural result of long-term trajectories coming to fruition at once, like waves from different storms meeting on the same shore. The pattern has emotion, but the explanation remains grounded. So the easy theories fall away. No hidden planet, no magnetic trap, no secret force reaching across space to drag these objects into line. What remains is subtle and scientific. A convergence worth watching, not fearing. Something interesting enough to study, not sensationalize. Something that encourages patience rather than panic. But there is another kind of alarm being raised, one that has nothing to do with doomsday. So if this isn't a doomsday parade, what kind of alarm are astronomers actually sounding? Whenever the sky grows busy, there is a familiar reflex in the modern world. Someone, somewhere, will declare disaster. A cluster of comets appears, an interstellar traveler enters the solar system, and social media begins stitching them together into a narrative of doom. Headlines sharpen the angles, thumbnails add flames, every anomaly becomes a countdown. But none of that noise reflects what astronomers are actually saying. The tone inside observatories and research groups is quieter, steadier, and far more grounded. This is not a doomsday clock. It is a scientific alarm, an invitation to pay attention, not to panic. The first step in clearing the air is the simplest. None of the known comets in this swarm are on a trajectory that intersects Earth. Their closest approaches are safe, predictable, and mapped with comfortable margins. The interstellar visitor 3I Atlas is on a hyperbolic path that will never bring it near our planet. If you sift through the observations, the orbital calculations, the ephemerides, There is nothing in the data that suggests danger. What the swarm represents is not threat, but timing. Not collision, but convergence. So where does the alarm come from? Not from fear of physical harm, but from something more subtle. The possibility that a rare scientific opportunity might pass unnoticed if we don't gather enough data. In a year shaped by solar maximum, when the sun's magnetic fields surge and twist and crackle with activity, every comet becomes a tiny probe drifting through a storm. Their tails reveal the structure of the solar wind. Their sudden brightenings trace interactions with radiation and plasma. And when an interstellar object enters this complicated environment, the chance to observe its behavior becomes even more precious. The real emergency isn't that the sky is falling. It's that the data might slip away if we don't look carefully enough. This is why astronomers are attentive, not anxious, not alarmist, just aware that this is the kind of moment future researchers might look back on and say, if only we had recorded more. Comets are transient. They make brief appearances and then return to the outer dark for centuries. An interstellar visitor is even more fleeting. Once 3I Atlas swings around the Sun, it will be gone forever. What we learn now may be the only glimpse humanity gets of the region it came from. The chemistry, the temperature, the environment of a distant system we will never see directly. The phrase "has been following" becomes richer in this context. It doesn't imply pursuit, it implies history. These comets have been moving inward for decades, shaped by nudges and perturbations millions of miles from Earth. And 3I Atlas has been crossing the interstellar medium for untold ages. Their convergence tells a story, not of intent, but of origin. A story about the environment through which they traveled, the forces that pushed them, the dust and gas that surrounded them. Even if the swarm and the interstellar visitor are unrelated in a direct sense, their shared arrival window offers a layered portrait of the space beyond our solar system. Understanding that portrait means watching carefully. It means comparing how different objects respond to the same solar conditions. It means monitoring the sun storms as much as the comets themselves. It means recognizing that these overlapping timelines are a rare alignment in a universe that usually spreads its mysteries thin. For listeners, this shift, from imagined danger to scientific opportunity, can feel like a gentle exhale. The sky is not threatening us. The sky is revealing something. Sometimes the most urgent thing is not to survive the night, but to understand it. When astronomers sound an alarm, it is usually because the window for understanding is narrow. These comets will fade. Their tails will vanish. The interstellar visitor will shrink into darkness. What remains will be our measurements and whatever truths we manage to extract from them. This is the tone that guides the rest of the journey. Not fear, but curiosity. Not dread, but attention. To understand the swarm, we have to understand the strange object they seem to be trailing behind. And that brings us to the traveler at the center of this crowded sky. A visitor with no return ticket. 3I Atlas. For most of human history, everything we studied in the sky belonged to our own sun. Planets, moons, asteroids, comets. Every familiar object traced orbits bound to the same central star. That changed only recently, in the span of a single decade, when the first unmistakable signs of visitors from beyond our solar system appeared. The first was Oumuamua in 2017, a strange, tumbling shard that defied easy explanation. The second was Tushi Borisov in 2019, a true interstellar comet with a more familiar tail, but a chemistry that hinted at alien origins. And now, for the third time in human history, an object from another star system has wandered into our backyard. This one is called 3I Atlas. To understand how rare that is, Consider the distances involved. Our solar system is a tiny island in a vast cosmic ocean. The nearest star is more than 4 light-years away, 40 trillion kilometers. Objects drifting between stars travel in near-infinite darkness, unbound by gravity for most of their journey. The fact that one of those objects is passing close enough for us to observe it is extraordinary. The fact that it is happening for the 3rd time within a human lifespan is even more astonishing. Interstellar objects are defined not by where they come from, but by how they move. Their paths do not loop around the sun. They streak through the solar system on hyperbolic trajectories, curves that bend once and never return. Their speeds exceed the escape velocity of our star. Their orbits cannot be explained by interaction with planets. They arrive unannounced and depart forever. They are, in the most literal sense, travelers from other suns. 3E Atlas follows this pattern. Its trajectory is unmistakably hyperbolic, with a velocity high enough that nothing in our solar system could have launched it. Its inbound path cuts down toward the sun from far above the ecliptic, angled just enough that it passes through the same celestial neighborhood as the swarm of comets brightening this year. Its inclination is neither aligned nor opposed to the planetary plane, just offset enough to brush through the region where we keep our eyes trained. When astronomers traced the trajectory outward into the past, the line pointed away from any familiar source. It did not come from the Oort cloud. It did not emerge from any slow, looping reservoir. It came from the interstellar medium, where distances stretch into the unimaginable. Then came the surprises. 3I Atlas began showing activity long before it should have. Most comets do not start shedding material until they are within a comfortable distance of the sun, where heat begins to vaporize their frozen surfaces. But this object brightened earlier, farther out, as if it carried materials that required very little warmth to sublimate. That early activity hinted at something unusual, either supervolatile compounds not common in our own comets, or an internal structure altered by conditions in a different stellar system. Its brightness curve rose in a way that made some researchers pause. Not dramatically, not alarmingly, but curiously. Small variations that suggested temperatures and chemistry not quite aligned with the patterns we know. Every photon reflected from 3I Atlas tells a story, not about our solar system, but about the environment where it formed. If you want to glimpse another solar system, you don't always need a spaceship. Sometimes a piece of it comes to you. And yet, in this story, 3I Atlas is not just an isolated visitor. It is the object around which the year's narrative quietly organizes itself. The swarm of 7 comets does not follow it in the human sense. They do not respond to its presence. They do not change course because of it. But when you trace their orbits backward in time, something interesting emerges. The comets began turning inward years or decades ago. Their long, cold arcs converge into the inner solar system just as 3I Atlas happens to arrive. When charted on a timeline, the paths look like beads strung along a thread, some ahead, some behind, but all drifting into the same season. This is where the idea of has been following gains physical meaning. Imagine a region of space where debris drifts in a loose cloud. Fragments left over from ancient collisions, icy bodies pushed outward by dying stars, remnants of planetary formation in a distant system. Over millions of years, such material spreads, stretching into a long, diffuse stream. One piece becomes 3I Atlas. Others, far smaller and far older, wander into the gravitational reach of our sun at different times. Not because they are chasing one another, but because they were once part of the same distant environment. In that sense, 3I Atlas becomes the leader only because it is the most vivid messenger of that ancient region. The comets in the swarm, though born in our solar system, may resemble a faint echo of the same broad direction of motion, a coincidental alignment of trajectories shaped by gravitational influences that act over centuries. The leader, then, is not a commander, but a landmark, the most dramatic representative of a path traced across the galaxy. This interpretation replaces intention with history. It swaps drama for physics. It asks us to imagine not a parade, but a river, one that flows across star systems, carrying debris of many kinds, each on its own timetable. Some fragments reach the sun now, others will arrive centuries from now. And 3i Atlas, bright and strange, is simply the piece large enough for us to notice in detail. This perspective also explains why astronomers are so fascinated. Interstellar objects grant a kind of natural sampling mission. They bring with them the chemistry of their birthplace, the temperatures, radiation levels, and dust composition of a star we cannot see. Their spectra act like fingerprints from another neighborhood in the galaxy. Each measurement tells us something about conditions we otherwise have no access to. In a universe filled with mysteries, few opportunities feel as precious. As the story moves forward, the central question becomes clearer. To see whether anything is truly following 3i Atlas, we have to trace its path through our solar system. Soon, we'll see how its orbit lines up with the swarm around it. When you look at a map of the solar system, it is tempting to imagine it as a flat, orderly diagram, a set of circles and ellipses neatly arranged around the sun. But real space is messier. Objects move in tilted planes. They cross one another's paths at angles. Their orbits weave above and below the ecliptic like threads in a loom. To understand whether anything appears to be following 3i Atlas, we have to look at the geometry of its motion and the motions of the swarm around it. And in doing so, we begin to see why this year has captured so much quiet attention. Start with the basics. Every orbit has nodes, points where it crosses the main plane of the solar system. That plane, the ecliptic, is defined by Earth's path around the Sun, and most planets and many comets stay fairly close to it. When an object approaches at a steep angle, it slices downward or upward across this plane, appearing and disappearing above the familiar lanes of planetary traffic. When it approaches at a shallow angle, it skims the region where most of the solar system's activity is concentrated. 3i Atlas does not dive straight down like a dropped stone. Its path is inclined just enough to bring it into the same general latitude as many of the year's comets. It comes in from above the ecliptic, tilting gently toward the inner solar system, descending slowly rather than plunging. That subtle geometry matters. It means that, for a period of time, 3i Atlas occupies the same broad celestial band where our surveys detect most inbound comets, not because it is interacting with them, but because its path happens to thread through an active region. When astronomers plot its trajectory alongside the swarm, the picture becomes even stranger. Several of the comets reach their brightest moments, their peaks of visibility, near the times and positions where 3i Atlas passes certain orbital milestones. Not exactly on top of one another, not in lockstep, but close enough that when you see the chart, you pause. A comet flares to life near the place where 3i Atlas dips through the ecliptic. Another reaches perihelion as the interstellar visitor skirts the inner regions. Others brighten in sequence along a rough diagonal that resembles a trail. On some plots, it really does look as if a line of icy fragments has been trailing behind an interstellar visitor. This is where the phrase "has been following" gains a visual dimension. When you project all these orbits onto a two-dimensional plane, they form a kind of ribbon, a loose, uneven band of bodies that appear before, during, and after the path of 3I Atlas. It is only an illusion of perspective, of course. These objects are separated by millions of miles and decades of travel time, but the timing and placement can still feel uncanny, as if you've stumbled onto a secret map that the cosmos did not intend to reveal so plainly. Some of this effect comes from the way our brains work. The human mind loves continuity. It sees arrows and trails, even when nothing but coincidence connects the dots. The sky, however, only knows orbits. Yet even from a scientific standpoint, the alignment remains worthy of study. Certain comets in the swarm reach their critical orbital points, perihelion, maximum brightness, closest approach, within surprisingly short intervals of 3I Atlas, marking its own milestones. The alignments are not exact enough to prove a relationship, but close enough to raise eyebrows among researchers who have spent careers looking for patterns that matter. Meanwhile, the interstellar visitor continues along its hyperbolic path, cutting a clean trajectory through the chaos of cometary debris. Its orbit, when drawn as a bright line on a dark chart, resembles a melodic phrase. Around it, the orbits of the swarm curve and arc like harmonies in a larger composition. The entire arrangement feels almost musical. 3I Atlas, carrying the main theme, the swarm providing the accompaniment, each line bending toward the sun in its own tempo. Still, a responsible scientist must say the next part plainly. Not every point of convergence means something. The solar system is large, but its traffic tends to funnel into predictable regions. Comets approach along preferred angles because of how gravity shapes their long periods. A few alignments can emerge naturally without implying a deeper connection. And yet, it is the density of the pattern this year, the number of comets moving inward along overlapping windows, that gives the impression of choreography. That impression is what makes the story compelling, not because it proves intention, but because it demonstrates how celestial mechanics can create patterns that feel almost narrative. The comets arrive one after another, passing through points that mirror the path of an interstellar traveler. Some brighten at moments that echo key transitions in 3I Atlas's journey. Others slip into visibility just as the visitor crosses into new sectors of the inner solar system. Each event on its own is unremarkable. Together they create a sense of motion that invites curiosity. It is also important to remember that we are watching the outer layers of long stories. These orbits were shaped by gravitational shuffles that happened generations ago, by encounters with giant planets, by distant nudges from the Oort cloud, by subtle drifts through regions thick with ancient debris. The appearance of simultaneity is something that happens only when we compress all that history into a single snapshot. When you zoom out far enough, the illusion of a line of followers becomes the natural result of many long journeys ending in the same season. But illusion or not, the picture remains striking. A visitor from another star system carves a path through the inner solar system. Around it, a grouping of comets reaches peak visibility in a tight cluster of months. Their orbits, mapped and stacked, resemble a series of strokes pointing inward. This is why astronomers study the plots again and again, not to prove a theory, but to understand why this moment feels different. And every orbit has a moment of truth, the point where it swings closest to the sun. Every orbit has a point where nothing can be hidden anymore. A comet may stay quiet for months, drifting cold and featureless through the outer dark. But once it sweeps close to the sun, all secrets begin to lift from its surface. This point is called perihelion, the moment of closest approach, and it acts like a spotlight in a quiet theater. Under that heat, ice boils, dust erupts, and chemicals trapped for billions of years reveal themselves in sudden, luminous detail. For astronomers, perihelion is less a destination than a peeling back of layers. It is where an object finally shows what it is made of. In the case of 3I Atlas, perihelion carries even more weight. This object has already surprised researchers by becoming active far from the Sun, glowing with a faint halo of vapor long before the expected threshold. As it continues inward, each degree of warming will coax new materials to sublimate. The most volatile compounds go first, things that evaporate at incredibly low temperatures. Then, as the Sun's radiation grows more intense, deeper layers respond. This sequence creates a kind of chemical timeline, an unwinding of the object's history. We see hints of the environment where it formed, the dust it collected, the temperatures it endured. Minute by minute, perihelion turns its surface into a record we can read, even from millions of miles away. For the swarm of 7 comets, perihelion is equally revealing. Most of them are expected to brighten predictably as they approach the Sun, shedding gas and dust in familiar patterns. But perihelion also allows astronomers to test something subtler, whether any of these comets show outbursts synchronized in time or in character with the behavior of 3I Atlas. It is a delicate question, and the goal is not to force a conclusion. Instead, it is to notice whether the timing of these brightening events hints at shared sensitivities or similar compositions. In a year already rich with coincidences, perihelion becomes the moment where nature either strengthens the pattern or gently dissolves it. This connects directly to the idea of has been following, not in the sense of pursuit, but in the sense of shared origin. If 3I Atlas and some members of the swarm carry material shaped by similar physical conditions, temperatures, dust densities, irradiation levels, those similarities may emerge here. Not as a perfect match, but perhaps as parallel behaviors. Comparable color changes in the coma, similar spectral features revealed under sunlight, or aligned timing in small surges of brightness. If these objects share a distant birthplace, perihelion is where their shared story might leak out, but it is equally possible that nothing unusual will happen. A lack of correlation can be its own kind of answer. If the comets behave entirely independently, some flaring early, some late, some barely reacting at all, it suggests that their convergence this year is purely statistical, not tied to any deeper shared physics. Perihelion does not guarantee drama. It guarantees truth, even if that truth is modest. The emotional tone of this phase is quiet anticipation. Astronomers are not looking for spectacle. They are waiting for clarity. Telescopes across the world will take rapid sequences of images, collecting spectra, measuring faint shifts in brightness. Observatories will compare notes, watching for signs of fragmentation, jets of gas, or sudden plumes. And with each new data point, the picture grows sharper, slowly, carefully. Sleep-friendly science, measured not in heartbeats but in photons. Perihelion also serves a narrative role. It is the scientific crescendo, not a loud one, but a meaningful one. Every theory introduced earlier in the story runs through this narrow gate. Does the swarm share any traits with the interstellar visitor? Do the orbits only appear coordinated? Does 3I Atlas behave like objects formed under our sun? Or does it whisper of other star systems? The answers, whatever they are, depend on these fleeting moments near the sun. There is something poetic about this. Objects that have traveled for centuries or eons or across the spaces between stars reveal their essence only when they brush against the sun's heat. It is like watching travelers remove their coats upon entering a warm room, exposing the colors beneath. Perihelion is not a test of survival, it is a test of identity. And the stakes, in their quiet way, are high. If astronomers do not gather enough data now, the chance will not return. Comets fade. interstellar visitors disappear into the black, the universe offers few replays. In this sense, the urgency is not about danger, but about opportunity. Space doesn't often give us yes or no answers. It gives us spectra, and we learn to read between the lines. And while these visitors sweep through their closest approaches, the sun is not sitting quietly either. Every 11 years, the sun turns a page. Its magnetic fields twist and tighten, sunspots bloom in dark clusters, and great storms of charged particles rise from its surface like unseen tides. This period is called solar maximum, and it has a reputation, not for danger, but for drama. The sun becomes louder, more expressive, more unpredictable. Its storms ripple through the solar system, touching every object caught in the flow of its light. And when that happens, comets become some of the most sensitive instruments we have. Solar maximum follows a cycle as old as the sun itself. Magnetic fields that begin orderly and simple slowly knot and tear as the solar interior churns. Those tangled fields erupt as flares, launching bursts of radiation across space. Coronal mass ejections, massive clouds of plasma, detonate from the corona and sweep along the solar wind like avalanches of light. These events take days to cross the distance to Earth, but comets feel them long before we ever do. Their tails are delicate, fragile constructions of dust and ionized gas, stretching millions of miles behind them. Under calm solar conditions, these tails flow cleanly. But during solar maximum, they become banners whipped by an invisible storm. A solar flare can kink a comet's ion tail. A coronal mass ejection can snap it like a loose rope. A shift in the solar wind can twist the tail into spirals or pull it into sharp, sudden angles. Sometimes a comet's tail vanishes entirely, momentarily stripped away before regrowing. Each effect is dramatic, but none of it alters the comet's path. The nucleus continues silently along its orbit, untouched by the violence playing out behind it. What changes is the appearance, the visible signs that respond instantly to the sun's mood. Now imagine not one comet, but seven. 7 objects scattered across the inner solar system during the most turbulent phase of the sun's cycle. 7 fragile tails exposed to the same storm front. 7 bodies reacting independently but simultaneously to the same waves of magnetic force and plasma. If you observe them casually, photographs posted online, brightening curves annotated with dates, time-lapses from backyard telescopes, it can look like choreography. One tail bends sharply on a Monday, another blossoms with fresh gas on a Wednesday, a third fragments the following weekend. Put those events together, and the pattern feels intentional, like a dance with cues and timing. But the truth is simpler and more humbling. Sometimes it's not the comets that are doing something strange. It's the star in the middle turning the volume up. This matters for understanding the illusion of coordination. When several comets happen to be in the inner solar system during solar maximum, they are exposed to the same environmental forces. Their tails will twist in the same intervals. Their activity will spike around the same storms. Their appearance will shift in ways that seem synchronized, even though each comet is responding only to physics, not to one another. It creates something that looks like a formation, but is really a set of individual reactions to a shared trigger. This offers another interpretation for the idea of has-been following. Instead of imagining that the swarm trails behind 3i Atlas with purpose, we can imagine this. They have been reacting together, shaped by the same solar weather, their visible behavior echoing the sun's cycles rather than any mutual connection. During solar maximum, the solar system feels smaller because everything is suddenly reacting to the same storm. From the perspective of someone watching the sky, this can be mesmerizing. The tails look like flags whipped by a strong wind. They flare, fold, and unfurl in long strokes of blue and white. Some appear to lean toward the sun. Others bend away in sharp, geometric lines. When several comets undergo these changes in the same month, the effect is striking, an impression that the sky has become animated, alive with motion. This is not mystery, nor coincidence, nor signaling. It is the sun, painting on the canvas of comet tails with plasma instead of pigment. Still, the emotional effect remains powerful. Watching multiple objects respond to solar storms at once feels like discovering a hidden order. Even astronomers, trained to avoid jumping to conclusions, describe a sense of awe during solar maximum. They know the science. They also know that no simulation can replace the feeling of seeing the sky move in ways that seem almost coordinated. What matters is that this coordination is a product of environment, not intent. The Swarm and 3i Atlas do not need to share a purpose to show similar responses. They are like plastic cups caught in the same river whirlpool, not connected, not communicating, but shaped by the same flow. The sun creates the impression of unity, and our minds fill in the rest. Understanding this helps temper the mystery with clarity. The alignment of comet behavior is not a code to decipher, but a reminder that the sun's influence extends far, far beyond its light. And in a year when many celestial visitors pass through that influence together, the patterns we see are as much about timing as they are about physics. What happens up there does not stay up there. It spills over into our technology, our nights, our myths. And down on Earth, those storms can feel very close indeed. When a solar storm sweeps through the inner solar system, it does not stop at the orbit of Venus or skirt politely around Earth. It keeps going, carrying charged particles and magnetic turbulence across millions of miles until it finally collides with our own planet's magnetic field. And when that happens, the effects ripple through our lives in ways most people never think about. A storm on the sun can flicker the lights in your living room. Earth has always been exposed to these storms, but only in the modern era have we built systems delicate enough to feel their touch. Power grids stretch across continents, transforming immense electrical flows into the quiet hum of daily life. Satellites circle overhead in narrow shells, relaying phone calls, navigation signals, weather imagery, financial transactions. GPS networks knit the entire world together. These systems are elegant and vulnerable. History has given us reminders. In March 1989, a powerful geomagnetic storm struck Earth and destabilized the hydroelectric grid in Quebec. In less than 2 minutes, the entire province went dark. Millions of people were left without power, not because a transformer failed or a line snapped, but because currents induced by the solar storm overloaded critical equipment. That same event created dazzling auroras as far south as Texas, but the beauty masked the fragility beneath. A storm born on the sun had reached across space and turned off a city. Other storms have knocked satellites offline, scrambled radio communication, and sent GPS networks drifting miles off their true positions. A spacecraft designed to operate flawlessly for years can lose its bearings in minutes under the right conditions. For engineers, these events are warnings of how thin the line is between normalcy and disruption. For the public, they are usually invisible, unless they coincide with something they can see. And in a year when the sky is unusually crowded with comets, coincidences grow louder. Imagine the scene. A brilliant comet appears in the evening twilight, its tail stretched across the horizon. People take photos. News stories trend. Social media lights up with images. Days later, a strong solar storm hits, disrupting satellite signals and causing brief outages in communication networks. A GPS glitch affects airline routing for an afternoon. A banking system delays transactions. None of this is unusual during solar maximum, but the timing overlaps with a sky full of visitors, and the human mind makes stories from timing. In moments like these, it becomes easy for the public to draw connections that do not exist. A satellite hiccup becomes caused by the swarm. A navigation error becomes linked to the interstellar visitor. A flickering grid becomes a sign that something is following us. These stories emerge not from malice, but from instinct. We look up, we see something unusual, and we search for meaning. This is why context matters. The real culprit behind these effects is the sun. Its magnetic storms shake our planet's magnetic field, inducing currents in power lines, distorting satellite orbits, and scrambling the data streams our world depends on. The comets are not causing these events. They are merely elegant indicators of the same forces affecting us. Their twisting tails act like weather vanes for space. They are beautiful, visible signs of solar behavior that would otherwise be hidden from view. In that sense, the swarm and three-eye atlas become screens onto which we project our interpretations. We see their synchronized reactions and imagine coordination. We see electrical glitches on Earth and imagine influence. But the actual chain of cause and effect runs the other way. The sun acts, the comets respond, and humanity interprets. Our stories grow out of the same atmosphere of uncertainty that ancient people once felt beneath the night sky. There is something humbling about this. We think of ourselves as masters of technology, yet a storm 93 million miles away can nudge our systems, distort our signals, and remind us that we live inside a magnetic cocoon far from being fully controlled. Our technology is how we touch space. Space weather is how it touches back. And when everything reacts at once, Earth's grids, satellites, comets in the sky, it becomes easier to see patterns that are not there. Still, these moments carry meaning, just not in the way social narratives sometimes suggest. They remind us that Earth is not isolated. They remind us that our systems are fragile. They remind us that the sun is a dynamic star and that its storms cascade through every layer of our cosmic neighborhood. They remind us that the boundary between space and daily life is thin, and they prepare us for the next turn in the story. If we react with circuits and satellites, we also react with stories. Our interpretations, fears, myths, and curiosities are as much a part of this year as the comets themselves. What began as a cluster of icy visitors has begun to touch our culture, our conversations, our sense of significance. Long before we had satellites to lose, we had something else to lose, our sense of certainty when we looked up. Long before we understood gravity, spectroscopy, or orbital mechanics, we understood stories. For thousands of years, comets were not icy bodies drifting through the solar system. They were messages, warnings, signatures of divine attention. When ancient astronomers in China recorded broom stars, they described their shapes not as physical phenomena, but as portents sweeping across the sky. In Europe, a bright comet could foretell the fall of a king or the rise of a new regime. In the Middle East, it might herald famine, illness, or the shifting of empires. These interpretations varied across cultures, but the pattern was nearly universal. A sudden visitor in the sky meant the world was changing. And it wasn't just the comets themselves. Many traditions spoke of celestial arrivals not as solitary events, but as processions. In old chronicles, gods traveled with retinues. Emperors appeared with entourages. Messengers of fate did not walk alone. They arrived with escorts. A leader trailed by attendants was a familiar motif, one that shaped how ancient people read the heavens. When the sky changed, it rarely changed in a single stroke. It unfolded like a courtly entrance, complete with symbolism and staging. This tradition casts a surprising shadow across the modern title. A swarm has been following. Those words touch an ancient part of the human imagination. They echo old codes in which visitors from above never journeyed alone. The idea of a celestial figure accompanied by a cluster of signs feels deeply familiar, even if today we view the heavens through telescopes instead of myths. A swarm reads like an entourage, a retinue of smaller figures trailing behind something greater. It fits a pattern older than writing. That instinct still lives in us, because we are storytellers by nature. When we look up and see multiple comets brightening in the same season, our minds reach for meaning. Not because we fear doom, but because we crave connection. In times of uncertainty, political, technological, climatic, we are even more drawn to the idea that the universe might be signaling something. We feel unsteady on the ground, so we search the sky for grounding. Modern people are not exempt from ancient impulses. When satellites glitch, when auroras reach unusual latitudes, when multiple comets appear in a single year, we begin to knit the threads together. The narrative emerges almost on its own. Something is approaching, something is being accompanied, something is following something else. We know the physics, we know the science, but the human brain is not built merely to observe, it is built to interpret. The swarm of 2025 becomes a canvas for these interpretations. A crowd of icy travelers arriving in the same general season feels symbolic, even if the science tells us it is a coincidence shaped by long orbits and solar activity. A lone interstellar visitor passing through our neighborhood becomes a focal point for meaning. We project stories onto its presence, the same way our ancestors projected stories onto Halley's Comet, or the Great Comet of 1811, or the tailed stars mentioned in Babylonian tablets. Why do we do this? Because comets are interruptions. They break the familiar pattern of the night sky. Stars stay where they are. Planets wander slowly and predictably, but comets appear suddenly, blaze briefly, and vanish for lifetimes. They demand attention. They disrupt the normal order, and in human experience, disruptions often come with messages. The idea of a swarm intensifies this feeling. One comet is an event. Several comets are a pattern. A pattern invites interpretation. Interpretation invites meaning. And meaning is something we generate instinctively, often before we realize it. Even people who understand celestial mechanics may feel a quiet unease or a quiet fascination when multiple luminous visitors appear at once. It is not superstition. It is psychology. It is culture. It is inheritance. This is why the phrase "has been following" resonates. It feels ancient. It feels like something encoded in old chronicles and temple inscriptions. It evokes the same instinct that once made warriors hesitate when a comet rose before battle, or made rulers consult astrologers when a new star appeared. We do not literally believe the heavens speak, but we still listen. And there is beauty in that, in recognizing that we stand in a long lineage of skywatchers trying to understand their place in the cosmos. They looked up with fear. We look up with curiosity. They sought signs of divine will. We seek signs of physics, formation, and chance. But the impulse to weave meaning into the unexpected is the same. We've always been good at turning comets into sentences. This moment in history is no different. Our technology has changed. Our models have improved. But the human heart still responds to patterns in the sky. The swarm becomes a mirror. It reflects our uncertainties, our hopes, our desire for coherence in a chaotic world. The interstellar visitor becomes a symbol of the unknown, and together they form a tableau that calls to something old and deep. The universe doesn't send us omens. We do that ourselves every time we connect the dots. So, When we say a swarm has been following 3I Atlas, what might really be trailing in its wake? For hours now, we've traced a path through crowded skies, ancient fears, modern data, and a year unlike any other. And still, the question lingers gently in the background, soft, steady, insistent. What has been following 3I Atlas? Not in the sensational sense, not in the language of fear or prophecy, but in the clear, grounded curiosity of someone who looks up at night and feels the quiet tug of something meaningful. To answer this question, we have to split it into two layers, the physical and the symbolic. One speaks the language of orbits and debris, the other speaks the language of insight and interpretation. Both matter, both shape the truth. Begin with the physical layer. Astronomers always start with coincidence because coincidence is far more common in the universe than intention. 7 bright comets in 1 year, overlapping loosely with the passage of an interstellar visitor, can happen by chance. The solar system has tens of billions of long-period comets. Their arrivals cluster. Their brightening windows overlap. The geometry of observation, Earth's position, the ecliptic survey coverage, can amplify the appearance of a pattern. In this view, the swarm is a rare but natural alignment of timing, nothing more. But there is a second possibility. When researchers simulate orbits backward in time, computationally rewinding trajectories for centuries, they sometimes find hints that strands of comets can share a dynamical origin, not a shared parent body, but a shared disturbance, a gravitational nudge from a passing star, a long-ago collision in the far reaches of the Oort cloud, an instability triggered by the slow dance of giant planets. These events scatter debris along similar inbound corridors. Spread out over hundreds of millions of miles, the fragments drift inward across decades or centuries, appearing to us as a loose chain. In this scenario, the comets of 2025 may not be random visitors. They may be members of a long, stretched-out stream, icy beads threaded along the same broad route. And 3I Atlas, coming from far beyond the solar system, could be crossing that stream at the exact moment when several fragments reach the inner regions. The result looks coordinated, even if the story behind it is slow, ancient, and impersonal. There is an even more intriguing possibility tucked quietly inside this idea, that 3I Atlas itself once drifted through a region rich in debris, perhaps ejected from a star system that experienced a major disruption, a failed planet, a shattered protoplanetary disk, a passing star that ripped material from its neighbor with tidal precision. Such events shape the galaxy's architecture far beyond what we can see. If 3I Atlas was born in such a place, if it is a survivor of a long-lost cosmic upheaval, then the idea of a swarm connected to it is not fantasy. It is simply physics, stretched out across impossible distances and unimaginable time. But even here, the connection is not literal following. It is shared origin, shared history, or shared gravitational ancestry. Nothing is chasing anything else. Nothing is shepherding. These objects are not a convoy. They are relics of motion, each fragment carrying the momentum of an ancient event, each on a trajectory long set before humans existed. A line of travelers who never met, yet whose stories echo one another through the language of their orbits. Backward simulations reinforce this possibility. When astronomers run millions of trial trajectories, rewinding the motion of 3I Atlas and the swarm, they find slight overlaps in directional vectors. Not perfect, not conclusive, but suggestive. Enough to say that a shared approach corridor is possible. Enough to raise questions worth exploring with better instruments and more data. And that brings us to the symbolic layer. What has been following 3I Atlas is not an alien fleet. but a fleet of questions. Questions about how often interstellar visitors pass through our neighborhood. Questions about how many fragments drift between stars, carrying silent histories of their birthplaces. Questions about how stable a planetary system truly is when viewed against the backdrop of the galaxy. Questions about what happens when a star system experiences a collision or gravitational shock that sends debris outward like sparks from a fire. Questions too about ourselves, because in a sense, we have been following 3-eye atlas, with telescopes, with software, with eyes pressed to the cold eyepieces of backyard instruments, with every data packet beamed back from observatories halfway around the world. Each time we point a camera at the sky, each time we refresh an ephemeris chart, each time we check a new spectral reading, we are trailing it, softly, persistently, curiously. The real convoy behind the 3-eye atlas may be invisible, a trail of insight stretching from one star system to another. To follow an interstellar visitor is to follow a breadcrumb trail left by the galaxy. It invites us to understand the violence of planet formation, the fragility of newborn stars, the migrations of gas and dust that create and destroy worlds. It invites us to widen our sense of cosmic scale, to remember that our solar system is not an isolated home, but a stop on a long galactic highway. And in the quiet of late night listening, there is another layer still. What follows an interstellar visitor into our lives is the way it changes how we see home, how we see the night sky, how we see our place in a universe that is neither hostile nor comforting, but vast and indifferent, and therefore strangely beautiful. The swarm becomes a reminder that even coincidences can be meaningful if they encourage us to pay attention. Even patterns without intention can spark deeper questions. Even brief visitors from other suns can shift the way we understand our own. In this way, the title resolves itself gently. What's been following 3-eye atlas is not a threat. It's a series of invitations to pay attention, to measure, to wonder. Not an omen, not a warning, not a choreographed procession, just questions and the chance to answer them. And now, as the swarm drifts on and 3-eye atlas slips back into the dark, we're left with one more journey to take. There comes a moment in every long celestial story when the brightness fades and the sky returns to its usual stillness, not abruptly, not as a curtain falling, but softly, like the last notes of a song dissolving into the air. That is where we find ourselves now, at the gentle ending of this journey. The comets have passed, the visitor has sailed on, and above us, the night spreads out in its familiar quiet. Somewhere far beyond the planets, 3-eye atlas is drifting back into the deep. Its arc through our solar system is almost complete. What once appeared as a curious glow in telescopes is now becoming a dim ember, retreating toward the darkness between stars. It carries with it no message, no warning, no secret agenda, only the memory of a brief encounter with our sun and the faintest whisper of the place it came from. The swarm, too, has finished its passage. Those streaks that once caught our attention have thinned and scattered. Their tails have faded. Their bright peaks are now just numbers in spreadsheets and faint lines on old charts. What filled the year with energy and motion has become quiet again, folded back into the slow rhythms of the solar system. We've spent time with them, not just as icy objects, but as characters in a story. We've looked at the swarm and at the interstellar traveler and at the invisible currents that shaped them. And through them, we looked at ourselves, at the patterns we search for, at the meaning we long for, at the calm that arrives when we stop trying to force answers and simply let the sky be what it is. Now, in this moment, the story no longer asks anything of you. You are not expected to analyze or predict or keep watch. You are invited simply to rest. Let the unanswered questions drift for a while. Let them belong to tomorrow or next year, or to future astronomers who will trace the paths of visitors we have not yet imagined. There will always be new comets, new wanderers, new mysteries, and each generation will follow them in its own way, just as we followed 3E Atlas tonight. Right now, all you need is this: a quiet place in the dark, a slow breath, and the knowledge that you are part of the same universe that carried these travelers to our doorstep. You are small in scale, yes, but small the way a grain of sand is part of a beach, or the way a drop of water is part of a calm sea. Not insignificant, connected. Imagine yourself lying beneath a wide sky, even if you're indoors. Imagine the stars above you, steady and patient, watching without judgment. The comets are gone, but the peace they leave behind lingers in the air like a soft glow. You don't have to reach for anything. You don't have to hold on to anything. You can let go. There is no need for shock here, no final twist, no complicated idea waiting at the end. Only quiet, only the slow rhythm of thought becoming softer, lighter, easier to carry. You might feel, for a moment, the same stillness that fills the space between stars. A stillness that doesn't ask for attention, but welcomes it if it comes. Tonight, the swarm has moved on, but the calm it leaves behind is yours to keep. So if your eyes are growing heavy now, let them. If your breathing slows, allow it to. The universe will continue its ancient motions without your effort. It will turn and drift and shine gently through the night. You don't need to stay awake to witness it. You don't need to stay alert to be part of it. You belong here, in this quiet corner of the galaxy, wrapped in starlight older than memory. You can rest. The sky will keep watching, even when you close your eyes. So if sleep is beginning to follow you now, just let it. The universe will still be here in the morning.